What could Starship launch with its 9-meter fairing? How can we possibly be ready for Mars? What happens with information in a black hole? And in Q&A Plus, when can you be confident that Planet 9 doesn't exist? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get to the questions. Ed Skeptic. Biosphere 2 didn't work on our hospitable planet, so how are they really going to do it on the utterly inhospitable moon or Mars? Yeah, for those of you who haven't heard about it, Biosphere 2 was this experiment done in the Arizona desert, just outside Tucson. And I've visited it, and it's amazing, where they were trying to create this fully enclosed habitat that was self-sufficient. So they had a bunch of people who went into this thing, they sealed it up, and they had enough plants inside of it that they would recycle their air. They were growing their own food, recycling their water. They had animals, and they were trying to see how long they could run this experiment before it went off the rails. And it turns out that they hadn't fully cured the concrete, and so it was extracting oxygen out of their environment, and they were getting less and less oxygen. More carbon dioxide was building up, and in the end they had to let in some oxygen to replenish the environment, and they weren't very forthcoming about what they were doing. There's some great documentaries about this. I highly recommend it, and if you can get a chance to go and see Biosphere 2, it is really inspiring. And that is not the only attempt that has been done. So the Chinese have a version of this they call the Moon Garden. And it's the same thing where they have enclosed it, and not as complicated and architecturally satisfying as the Biosphere 2 is, but they were able to go about a year and have it be fully self-cycling. So we know in broad strokes how to do this, but I am just shocked that there aren't continuous Biosphere 2 level experiments going all the time, that there should be a Biosphere 2 or whatever is the version of it, right? Biosphere 2, because there's the regular biosphere, the Earth, and the Biosphere 2 is the, us creating a secondary biosphere. So we need something like that. And I don't think Biosphere 2 is the right facility for it. It was kind of overbuilt for what it was. And maybe it's the Chinese version with the Moon Garden. That's going to be the way to go. But you need some place here on Earth where people are trying and testing out, can we do long-term cycling of our environment and keep everybody alive? And you're absolutely right that we need that for a moon base or a Mars base. But we can still add inputs. So with the Biosphere 2, one of the things they said was, well, we're not going to add any inputs. We're not going to add any food. We're not going to give them anything. They're going to try to live off just essentially the sunlight that is coming through the biosphere glass. That is going to keep them alive. And we can supply food, water, additional stuff to a lunar base or to a Mars base. The trick is that that'll be the limitation, that if we can't keep up with their needs for the food, for the resupply, for medical equipment, for whatever, then they will starve and die. So we've got to be able to have them be as independent as possible, and then we can replenish them from there. And the moon is the perfect place to do this. The moon is very close. The moon receives the same amount of sunlight as the Earth does, although it's broken up into 14-day-long days, 14 days of day, 14 days of night. So that will be a challenge that will need to be overcome. But if they run out of something, they run out of toilet paper, you can send more toilet paper in 3 days on the next resupply mission. And I think that we won't even imagine having a long-term presence on Mars until we have demonstrated for a decade, right? 20 years maybe of long-term presence on the moon, that we have just dialed in all of the engineering challenges that it's going to take. Now, you can send people to Mars earlier than that, but you might be sending them to their death. So you just have to be aware that that is one of the concerns. So yeah, I think we need to prove that we can understand all of the factors, all the variables to running a fully enclosed ecosystem. And it gets complicated, right? What about medicine, right? Can we grow various medicinal plants that can be, or can we create biolabs that will be able to 3D print the kinds of things that we need? When you sort of think about all the things that you need every day, there's this short tail. You need to breathe, you need water, you need food, but then there's this longer tail. You need certain vitamins and minerals in your, in your diet. You need, you know, replacement parts for various pieces of equipment. It goes on and on and on. You need various kinds of medicine. And when you think about all of the prescription medicine that, I'm sure if all of us watching, all of you watching this episode right now wrote down all the prescription medicines that you are on, we would have a list that probably was hundreds long. Right. And that's just like regular human beings, taking prescription medicine. And so like, how do we supply all of that over the long term? So these are all of the challenges. These are the engineering, the nitty gritty detail that we need to be able to figure out. And we have scarcely begun. That when you think about what happens with the International Space Station, we deliver, resupply, we pretty much deliver them everything they need. All of their food, all of their water. Yeah, they do have some reclamation of water. They grow a couple of plants on the station, but really all their food, all their water, everything is being supplied, all of their atmosphere, everything. So we need to be able to get better at that, and we're just not. It's time to shout out our new patrons at the $5 level and above. Dave Gallagher, Danny, Paul O, The Memes of Destruction, John T, Michael Zoch, Manfred Brewer, Mark Canaday, Creed, and Groovy Beats. Join the community at patreon.com/universe today. Brett Ostrander, can you speculate on potential changes to payloads once Starship is constantly launching to low Earth orbit? The 9-meter diameter should be a game changer, right? Yeah, in theory, Starship is a complete and total game changer, an utter disruption to the launch market. That right now, launch costs, even with, say, a Falcon 9 is in the $60 to $90 million range. Falcon Heavy is in the, 150-ish million range. Other providers can be more expensive, although there aren't many providers left that will compare. Ariane Space is going to cost you the hundreds of millions. United Launch Alliance doesn't launch very often anymore. Now we've got Blue Origin, but I don't even know what the cost of a Blue Origin launch is. I mean, there've only been 3 so far. So in theory, I have to keep saying in theory because we haven't seen this happen yet. SpaceX Starship, with its 9-meter fairing, will have one of the lowest launch costs of any provider that's out there. That you will probably pay in the tens of millions of dollars to refuel and refurbish Starship after every launch. I mean, we don't know what the final launch costs are going to be. We've heard Elon Musk say that it's going to be, I don't know, $75 per kilogram or something like that. Like, it's going to be super cheap. Reality, I think, is that it will be affordable, but it'll be as much as SpaceX is able to get away with and still corner the entire launch market. But at the end of the day, this cavernous 18-meter high, 9-meter cross fairing will just be so big and be able to handle so much. You could fit any existing spacecraft in there, multiple spacecraft. And if it's going to be cheaper to launch them on a Starship than any other provider, then everyone's going to flock to these Starships. And in the short term, there aren't enough payloads that, if a single Starship can launch multiple times in a day, but even if it can only launch once a week, then it's going to churn through the entire launch backlog quickly. Of course, we haven't seen Starship successfully complete its full mission. We've seen the reuse of the booster. We've seen the Starship itself soft land at a designated place without being burned up in the atmosphere, but we haven't seen it return to the launch site, land, then the whole stack get reused. Like, that's the level of reuse that we need to get to for all of these big investments to start to really pay off for Starship. So ideally, in the dream, we enter this new era of completely reusable, fully reusable 2-stage rockets. That would be amazing. The reality is that we probably have more engineering challenges to overcome before this actually happens. But it feels like this is inevitable. This is the future. And it's just a matter of some company, whether it's happening in the US or whether it's China, which is working on their own versions of this technology as well. One of them is going to come up with it first. Dougal, Nancy Grace Roman telescope is under budget and ahead of schedule. When was the last time a space endeavor did that? I can't think of any other time that a telescope was under budget and ahead of schedule, but I can think of lots of examples of NASA missions where they came in on time and on budget. A classic example of that was the TESS mission, the Transiting Exoplanet Survey Satellite. I forget the exact budget, but it was, a few $100 million. It was delivered exactly on time and exactly on budget. And NASA is very good at building missions that are on time, on budget. You probably didn't realize how many of the missions that have come out of NASA were on time, on budget, especially the ones that are done within the organization. Like the folks at NASA JPL, they're very good at what they do. Even the folks at Goddard, very good at what they do. It's when you have external contractors, you have legislation from Congress, there's a lot of laws written into it, a lot of back and forth. These things and the goals drift and shift. Even like when you think about the space shuttle, you can go back and look at the original designs of the space shuttle. It was pretty cool. You would have this launch aircraft, and then the space shuttle would be attached onto the top of it, and then they would be lifted vertically, launched like a rocket, and then the carrier aircraft would detach and glide back down and land on Earth, and then the space shuttle would fly to orbit, and then it would return to Earth, glide down. It was a fully reusable two-stage rocket system. But then the military had requirements, Congress put in additional requirements, and they had to change the design to make it a lot less reusable. In the end, only the orbiter part and the solid rocket boosters were reused. They had to throw out the fuel tank every time. But a lot of NASA missions come in on time, on budget. We just have this classic glaring example of the one that didn't, which was James Webb. And then the ones that are in process. I mean, I think the Mars sample return mission, that was one that was already at risk of having budget creep. But a lot of the times, this is a leadership problem, not necessarily a problem from the engineers. Mad Million, if Hawking radiation evaporates black holes, where does the information go? Good question. That is the information paradox, right? That when you sort of think about the classical idea of this, you have a black hole. The black hole is accreting material on the black hole, that the material goes into the black hole and turns into black hole. And then the black hole lives forever as this growing sphere of information. That's fine, right? Information can go in, it's like whatever happens, it gets mangled and it becomes part of the black hole and it's locked away forever. But Hawking realized that black holes, and now it looks like probably everything, all mass, all matter, will evaporate over time. Neutron stars, black holes, etc. And that as this black hole is evaporating, it's giving off pure energy, and that energy has no connection to the information that went into the black hole in the first place. And that is a no-go. That is a thing you're not allowed to do. And the answer to that question, how can you destroy information inside the black hole, is something that a lot of people have been trying to come up with an answer. But until this point, it's the information paradox. And there's lots of ideas, like maybe the, one interesting thing is that the surface area of the black hole is sort of your maximum level of entropy, and that the information about what goes into the black hole could be encoded on the surface of the event horizon of the black hole. And then as the black hole evaporates, that information is then re-encoded on the energy as it leaves the black hole. And so it's not lost, it's just changed. Or it might be that it is truly destroyed, and that violates other various physics concepts that are going to have to be resolved. So that's why they call it a paradox. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We'll call it Q&A Plus. And this week's bonus question, when can we be confident that Planet 9 doesn't exist? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions into the YouTube comments, everybody who put your questions into the live stream that I record every Monday at 5 p.m. Pacific time. I'm back in my home office, and so the live streams will continue until morale improves. Now I'm going to get your suggestions in a second, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Karen, Chuck Hawkins, Commander Balak, Dark Finga, David Gilton, David Matz, Enthralling Reading and Math for Toddlers, Eric Lindstrom, Evan.pro, James Clark, Jerry Mattern, Jim Burke, Jordan Young, Marcel Sutz, Michael Purcell, Nordspace, OneSifferAnimals.org. Please follow my nephew at VBrick6994, Rankaidi, Richard Williams, Sean Sargent, Stephen Falamoney, Team 49, Telescope Canada, Vlad Chiplin, Wolfgang Klutz, and Zelda Board Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So about 2 years ago, I did a really fun video with two of my friends, Dr. Moya McTeer and Dr. Dakota Tyler, and we ranked all of the answers to the Fermi paradox and put them into, of course, the classic S to F tiers, and just had a great discussion about sort of all the different responses to the Fermi paradox, and it was well received. We had a good time. I really enjoyed moderating a conversation with two other people where I could sort of let them talk and just have the banter back and forth. It was a lot of fun. And I have lots of people that I would love to do these kinds of videos with, but I need like a framework to turn that into a thing. And so I would love to hear your suggestions on what are some ideas that you would like to see ranked. Realism of science fiction technology, the best kinds of technosignatures for us to search for, the difficulties of various Mars exploration technologies, the biggest mysteries in the universe. I don't know. You tell me. So if there's some stuff that you think would apply really nicely, where you could put in some idea and then I could go, oh, I know who the perfect person is to opine about this idea. And then we can have this really fun discussion. And like, of course, it's ridiculous that you are putting these things into S through F tier. And yet it is just so much fun. And I want to do more of those kinds of videos. So I just want to sort of open up the floor to you. Give me some recommendations for some stuff that you think would fit nicely into getting tiered. And then I will try to make the rest of it happen. All right. We'll see you next time.